We can use the reactivity series to predict what's going to happen in a reaction, and these are displacement reactions we're talking about. So here is the reactivity series with the most reactive at the top here and least reactive at the top here. And you'll notice I've put carbon and I put hydrogen in there. I've put these in a different colour because these are non-metals, whereas the reactivity series is the reactivity series of metals. So if we notice down here, we have silver, gold and platinum. These are found when they're found as metals, as just the pure metal. So because they're so unreactive, you're just going to find them, lying around in the ground as silver, gold and platinum. If you've ever been on holiday to Wales, you might have gone panning for gold in a river and you'll find teeny tiny little specks of gold just lying there. The ones in the middle here, zinc, iron, tin, lead and copper, are the metals that we use a lot every day. So you can have copper pans in your house, you can have lead on the roof, or you can have iron in nails. And these ones are a little bit reactive, but not so reactive that we can't use them in everyday life. The ones at the top here, potassium, sodium, calcium, these ones are highly reactive. So potassium will react very quickly. Sodium is one of the alkaline metals. If you've seen this demonstration in school, you'll notice that it has to be kept under oil because it's so reactive it will react with the air around it. Now we can use this reactivity series to do a few experiments and see what happens when we mix things up.
Here we're going to be looking at the reactivity of metals. So we have magnesium ribbon, magnesium sulfate, copper, copper sulfate, zinc, zinc sulfate and iron sulfate. And I've just laid them out here. So we've got magnesium, copper, iron and zinc. So here we are again, we have magnesium, copper, iron and zinc, and in this one I'm going to put magnesium sulfate. And all we need to do is just pop a few bits in and watch for the reaction. Just squash that down a little bit to get it all covered in the magnesium sulfate. I'll just pop a tiny bit more on top. So that's the magnesium sulfate. Then in this one here I'm going to put copper sulfate. And we can see here that the magnesium is reacting quite a lot already. We can see the zinc's going as well, and this one I'm going to put iron sulfate. Oh, lots of reaction going on there. So we can see there the magnesium's fizzing away all over the place. And in this one I'm going to put zinc sulfate. So there we go, there are our reactions, the obvious ones that you can see are the magnesium reacting with things. So the magnesium, we can see the magnesium with copper sulfate, magnesium with the iron sulfate and the magnesium with the zinc sulfate. Then we have the copper with magnesium sulfate, with the copper sulfate, with the iron sulfate and with the zinc sulfate. Then we have the iron with the magnesium sulfate, with the copper sulfate, with the iron sulfate and then with the zinc sulfate. The zinc with the magnesium sulfate, with the copper sulfate, with the iron sulfate and again with the zinc sulfate.
So here we have our results table, and when we mix the metal with the metal sulfate, we are not going to have anything happen, so I'm just going to cross those out. Now magnesium, we can see over here, is much more reactive than anything else. So the magnesium is going to want to keep the sulfate for itself. so we are not going to get any reactions with the magnesium sulfate and anything, whereas the magnesium metal is going to have reacted with everything. Now we've already filled in this box here and this box here. If we look at copper and iron sulfate, we have copper here and iron here, so you wouldn't expect any reaction to go on here. And then we have copper here and zinc up here. So zinc's more reactive, it's going to want to keep sulfate, no reaction going on there. That's exactly what we saw in the experiment. Now we have iron and copper sulfate. Iron is here, copper sulfate is here, so the iron is more reactive, so it's going to want to take the sulfate away from the copper. So we are going to get a reaction, and that's what we saw. If we look at this box here, iron and zinc sulfate, iron and zinc are very close to each other, but iron is still below zinc in the reactivity series, so we are not going to get a reaction. If we're moving on to looking at zinc and copper sulfate, zinc is here, copper is all the way down here, and because copper is less reactive than zinc, it's not going to be able to keep hold of that sulfate, so we are going to see a reaction. If we're looking at zinc and iron sulfate, zinc is here, iron is here, again very close to each other, but the iron is lower than the zinc on the reactivity series, so we are going to get a reaction in this circumstance, and this is exactly what we saw in the practical we've just done. So for all the reactions where there was no reaction, what we started off with, copper and the magnesium sulfate, is exactly what we end up with, copper and the magnesium sulfate. And this is true for all of them: iron, magnesium sulfate, zinc, magnesium sulfate, copper and iron sulfate, copper and zinc sulfate, iron and zinc sulfate. Just because we mix two things together doesn't mean there has to be a reaction. Here there was no reaction, so what we started off with is exactly what we end up with. One of these situations where we did get a reaction is when we have magnesium and copper sulfate here. Now, the reaction that's actually going on is the magnesium is more reactive than the copper, so it's taking the sulfate away from it. Now, I've drawn it here as some blocks for you to help you visualise what's going on. The magnesium is then going to end up with the sulfate, which is going to leave the copper on its own. So we can write the rest of the equation as magnesium sulfate plus copper. Now if we want to extend this, we can look at the symbol equation. Magnesium, copper, and then exactly like we've just done, it is going to be magnesium sulfate plus copper. Another situation where we got a reaction is with magnesium and the iron sulfate. So yet again, the magnesium is just going to take the sulfate away from the iron, and then the iron is going to be left on its own. Writing the word equation, it's going to be magnesium sulfate and iron. Again, here we have magnesium and zinc sulfate, and what the magnesium is going to do is to take the sulfate away from the zinc, and the zinc will be left on its own. So we will end up with magnesium sulfate and zinc. When we reacted the iron with the copper sulfate, exactly the same sort of thing is going to be going on. We are going to end up with iron, sulfate and copper. Reacting zinc and copper sulfate, our products are going to be zinc sulfate and copper. And finally, if we react zinc and iron sulfates, we'll get zinc sulfate and iron.
I really hope you found this video helpful. You can join my online classroom at Patreon, where you'll get weekly assessments so you can keep improving and at the same time support me. Subscribe to the YouTube channel so you don't miss anything. To keep up to date, you can follow me on Twitter or like me on Facebook. And for extra resources, blogs and all of the videos in order, you can visit my website, primrosekitten.com. Thanks for watching, guys. I really hope you enjoyed it. Any comments, questions or corrections down below, please.